Hey guys, all right, so in the last video we talked about how to calculate the empirical formulas. Now this time I'm going to talk about how to calculate the molecular formulas, all right? So now in this case, here is an example problem. A compound has a formula mass of 176.0 and an empirical formula of C3H4O3. So what is the molecular formula? All right, so what we need to do, or what we have and what we know, is that we know what's the formula mass of the molecular formula. Here, this is it. And then I tell you, hey, this is the empirical formula, okay? Now, to find the molecular formula, so what you have to also remember is that the molecular formula is a multiple of the empirical formula, all right? And so if knowing that statement, if we figure out what's the molar mass of this, of the empirical formula, it's going to be the multiple of the molar mass of the molecular formula, all right? And so what we want to do first is we need to figure out, okay, what is the molar mass of this? And once we could figure that out, then it should be easy to figure the rest out. So what's the molar mass of C3H4O3? Well, you go in the periodic table, and then you figure out the molar mass of this. So, for example, we have carbon. Carbon has a molar mass of 12.01. We multiply that number by 3. We have hydrogen. It has a molar mass of 1.008. You multiply that by 4. We have oxygen. It has the molar mass of 16.00. You multiply that number by 3. We add this up together, and we get roughly about, really close to it, 88.0 grams per mole. All right, so that's the empirical formula's molar mass. And I tell you what's the molar mass of the molecular formula. So once again, we want to know, all right, the multiples. Remember, empirical formula is just a multiple of the molecular formula. Or actually the other way around. The molecular formula is the multiple of the empirical formula. So we need to figure out how many times bigger our molecular formula is to our empirical, okay? And so if this is the case, well, we know that the molar mass of the molecular formula is 176, okay? And the molar mass of the empirical formula we just figured out, it's 88. Well, if we put this in the calculator, we realize that the molecular formula is 2 times greater than the empirical formula, okay? And so knowing that, we could just take this number and multiply by all the subscripts of the empirical formula. And you do that, our molecular formula, which I'm going to call MF, is C6H8O6. And that's your final answer. So, okay, so we're going to do one more example. All right, so here's a hard problem. A compound containing 5.9265% hydrogen and 94.0735% oxygen has a molar mass of 34.01468 grams per mole. Determine the empirical and molecular formula of this compound. So here we start out with just a percent composition of this compound that's containing both hydrogen and oxygen. And I'm asking you to find both the empirical and the molecular formula, all right? So the first thing you want to do is figure out what's the empirical formula. So we'll run through the steps that we did before, all right? So because this is in percentages, we could just assume, so when you add them up, it's 100%. We could assume 100 grams, and so that way we could keep the same number, all right? So we have 5.9265 grams of hydrogen here, and then we have 94. Actually, let me do this in a different color. We have 94.0735 grams of oxygen, okay? We'll get the molar mass. So we know that 1 mole of hydrogen is 1.008 grams of hydrogen. We know that 1 mole of oxygen is 16.00 grams of oxygen. Okay, so when you put this in a calculator, here we have 5.879 moles of hydrogen. And then for oxygen, we get 5.879 moles of oxygen. All right, so just like last time, you want to divide by the smallest number. And if you look at here, they're both the same number. All right, so it's 5.879. This is, we divide this by 5.879. And so we turned out that this is 1, this is 1. So our empirical formula is really just simply OH. All right, that's our empirical formula. So empirical formula. All right, so that's 1. Now we got to figure out what's the molecular formula. All right, so I tell you here on this side what is the molar mass of the molecular formula, and it's 34.01468. Okay, so we need to figure out how many times bigger is the molecular formula to the empirical formula. Well, in order for us to figure that out, we need the molar mass, okay, of the empirical formula. So we got the empirical formula here. Let's figure out what is the molar mass. All right, so kind of moving this around a little bit. So we have oxygen, its molar mass is 16.00. Hydrogen, its molar mass is 1.008. And so when we add this up, we get 17.008 grams per mole. So this is the molar mass of OH, or what we call hydroxide. Now we need to figure out how many times bigger is the molecular formula compared to OH. Well, let's go back to our problem. We see here once again that this is the molecular formula's molar mass. It's 34.01468. All right, so 34.014, I think it says 68, yes, 68, okay? And you will divide this by the molar mass of oxygen that we just figured, of hydroxide we just figured out, and it's 17.008. You plug this into the calculator, and what we get is 1.999. So since this number is so close to 2, we will just call this 2. All right, so what does this 2 mean? This 2 simply tells us that the molecular formula is 2 times greater than the empirical formula. So we'll take this number multiplied by all the subscripts of the empirical formula. So in this case, the empirical formula for hydroxide is just OH, so 1 O and 1 H. We'll multiply it by 2. And then so our grand answer at the end is O2H2. Okay, that's the answer.